Hi everyone, welcome to the fourth video of Module 7. Here we are going to learn about the multi-layer perceptron and study about different layers that comes together to build this whole multi-layer perceptron. And typically we'll be talking about input layer, hidden layers and the output layer. Let's get started. So now let's get started with the single and multi-layer perceptrons, which are the first type of artificial neural networks you will see whenever you talk about the deep learning. So in the single layer perceptron, what really happens is, it's very much similar to what we have already seen in our previous video when we had talked about the artificial neuron. But that's not all about it. It's not that all the input neurons are going to go towards only one artificial neuron. We can have multiple artificial neurons over here on top of this particular neuron or even below that, as you can see over here. So if I just cut this whole architecture into the first part, then this becomes a single layer perceptron. The whole concept of the single layer perceptron is that after the input layers where you have the input neurons, there is only one and final layer which you call it as an output layer. So that becomes your single layer perceptron. It can have only one artificial neuron or it can have a bunch of different artificial neurons as you can see over here. But then how is it different from the multi-layer perceptron? In the multi-layer perceptron, you don't just have two layers, that is input and output. You indeed have an input layer along with the output layer, but in between them, there is something which you call as hidden layers. So if you don't directly have input layer and output layer in your architecture, then this becomes your multi-layer perceptron if it has at least one hidden layer in between. And therefore, the image on the right belongs to the multi-layer perceptron. Now, what is the input layer, hidden layer, and output layer? How are they different from each other? What are the purposes of this kind of layers is what we are going to understand right now. So in the input layer, we have the number of neurons in the input layer, which is the number of input we feed to the neural network. And then no computations are performed in the input layer because this is the first layer. These are not actually the artificial neurons. These are just the kind of placeholders where we are having all the kind of input data, and therefore we call it as an input layers where no typical computations are performed. And then it is just used, as I mentioned, for passing the information from outside to the network. All right. So from the outside of the network, if you want to pass some kind of data into the network, we use this kind of input layers. And you will see this input layers found in all the type of artificial neural networks. Now, each inputs will have some influence on predicting the output. We have already seen this because of the weights that are associated with each and every input. So this is the type of influence I'm talking about over here. After this, we are having a hidden layer, which we typically also call it as a dense layer. Any layers between the input and output layer is called as hidden layer. Even if you see it in this particular diagram, we can see that in between input and output layers, there are two layers and both of them are named as hidden layer. By the way, this 10, 12, 12 and whatever is the number over here you are seeing is responsible for the number of neurons in that particular layer. For example, in the input layer, if you count, there are total of 10 neurons, 10 input neurons. That's why the dimension is written over here as 10. Similarly, if you calculate the total number of artificial neurons in this layer and in this layer, each of them is having 12 neurons. And therefore, the 12 is written over here. And if I count these neurons over here in the output layer, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over here, the number is going to become r to the power of 10. It says that there are a total of 10 neurons in the output layer. So yeah, that's how basically the architecture looks like. So over there, if there are any kind of layers in between input and output, they correspond towards the hidden layer. And therefore, now we are talking about the multi-layer perceptron. Over here, it is majorly responsible for deriving complex relationships between the input and output. If you remember in the first lecture of the deep learning, I had already mentioned about this thing, that if you are having a complex data and a very huge data, we use deep learning frameworks. So over here, hidden layers are the one which are responsible to decode these complex relationships between the inputs and outputs. How exactly and all of these kind of things you will understand slowly and steadily as we go ahead in this particular program. So just have a patience for that. But yes, it is also responsible for learning the data representation and for extracting some of the features that are present over there that will be helping the network to understand what type of inputs will give what type of outputs. So this is all the things that are going to happen with the help of hidden layers. Now let's look into the final layer that we have in all the type of neural network architectures, that is the output layer. So after processing the inputs, the hidden layers will send its result to the output layer. So the number of neurons that we have in the output layer are basically dependent on the type of problem that network is trying to solve. For example, if we are trying to use a binary classification network, over there the output neurons could either be 1 or 2. So what is the reason behind 1 or 2? Let's say if even one particular output neuron has the value that is above a threshold, then we know that it belongs to class 1, or else it will be belonging to class 0. So if you want to display both of its probabilities, you can use 2 neurons. But then if I talk about the multi-class classification, over here, if let's say we are talking about 8 different classes, so I want to display all the 8 classes probability. So over there, the number of classes will be equal to the number of neurons that we have in the output layer. And then if I'm talking about the regression problem, that on the basis of the inputs, I have to predict what will be a particular value. That is a regression problem. So over there, even one neuron can be helpful in the output layer. So this is the type of thing we need to know, that in the output layer, the number of neurons are actually dependent on the type of problem that network is trying to solve. So yes, that's pretty much about the output layer that you need to know over here. And now if I just have to summarize everything over here about the single layer and the multi-layer perceptrons, in the single layer perceptron, we don't have a hidden layer. And if you introduce a hidden layer to your architecture, in that case, this will belong to the multi-layer perceptron. So now what is the purpose of each and every layer? Input layer is responsible to feed in the data to the architecture. Then outputs are responsible to get basically the outputs that we are having on the basis of all the kind of mathematical things that goes on in the backend. That is the unactivated output, then we activate it, so on and so forth. But then we also have this kind of hidden layers to decode a very complex kind of scenario that goes on in between the relationship of input and output. So depending on how much complex your data is, you can come up with different type of hidden layers with different type of hidden neurons within them. So yes, that's an overall idea of how a single layer or a multi-layer perceptron will work. So yes, we are done with this video over here. I hope you were able to understand the difference between the single layer perceptron and the multi-layer perceptron, and what are the different types of layers that makes this kind of multi-layer and the single layer perceptron. Now in the next video, I'm going to show you some different types of activation functions that we commonly use in this type of architectures.